In their relentless pursuit of knowledge about the universe, scientists have launched the Voyager 1 probe to explore space and gather valuable data. However, recent findings have revealed that Voyager 1 encountered a highly sophisticated alien object that has the potential to revolutionize our understanding of the cosmos. What exactly is this object, and how does it challenge our existing knowledge of space? Join us as we unravel the mysteries surrounding the extraordinary discovery made by Voyager 1 before it was shut down.
We have ignition, and we have liftoff, farther into the solar system than ever before.
Voyager 1's shocking discoveries. To us, living on Earth, the Earth is as huge as anything we've ever known. But the truth is, in the grand scheme of things, the Earth is just a small, almost insignificant player. The amazing space probe Voyager 1 was sent out to study the vast cosmos's intricacies, particularly interstellar space. During the long journey that Voyager 1 embarked on, he made different discoveries that helped scientists find answers to some questions that had remained unanswered for centuries. Our understanding of the vast universe has been expanded due to the operations of this space probe. The space object that Voyager 1 stumbled upon in its travels was a radio wave. Dr. Don Gurnett, one of NASA's scientists, was the one who detected when the space probe made contact with the radio waves. He found that the Voyager had collided with the radio waves when it approached the heliosphere, the border encompassing our solar system. Don Gurnett reported this to his colleagues at NASA, but they had a hard time believing it. They had their doubts and reservations. For one thing, no one had ever seen such radio waves before, and many researchers doubted Gurnett's explanation for the signals. For another, his measurement meant that the heliopause was depressingly distant. According to him, the heliopause was located considerably away from the Sun. To make it clearer, just imagine Neptune, which is the farthest planet from the Sun. It has a distance of 30 astronomical units from the Sun. But Gurnett said that the heliopause is much farther than Neptune is from the Sun. That claim made it harder for the scientists to believe Gurnett's theory. If true, it would take much longer than expected for Voyager 1 to reach interstellar space. The theory, though, and the radio waves weren't the only things that dumbfounded scientists. Another thing that left them speechless were the messages they received from Voyager 1 at some point in its journey. The scientists couldn't make heads or tails of the message, so it was feared that the beloved Voyager had reached its limits and was shutting down. The Voyager 1 probe is still exploring interstellar space 45 years after launching, but it has encountered an issue that mystifies the spacecraft's team on Earth. You'd agree that 45 years of traversing the solar system can take its toll on a spacecraft. NASA's Voyager 1 mission, which was launched in 1977, passed into what scientists call interstellar space in 2012 and just kept going. The spacecraft is now 14.5 billion miles away from Earth, the farthest that any man-made object has traveled, now that's some record. While Voyager 1 is still operating properly, scientists on the mission recently noticed that it appeared confused about its location in space without going into safe mode or sounding an alarm. According to Suzanne Dodd, project manager for Voyager 1 and its twin, Voyager 2, at NASA's Jet Propulsion Laboratory in California. In a statement, "A mystery like this is sort of par for the course at this stage of the Voyager mission. The spacecraft are both almost 45 years old, which is far beyond what the mission planners anticipated. The glitch involves Voyager 1's Attitude Articulation and Control System, or AACS, which keeps the spacecraft and its antenna in the proper orientation. The confusing thing is that despite the nonsensical messages sent by the Voyager, the AACS seems to be working just fine since the spacecraft is receiving commands, acting on them, and sending science data back to Earth with the same signal strength as usual. The problem is that the AACS continued to send confusing data to the spacecraft's team. NASA had to make a public statement to rationalize away the mumbo-jumbo sent by Voyager 1. However, the NASA statement did not specify when the issue began or how long it lasted. The agency said that Voyager personnel will continue investigating the issue and attempt to fix or adapt. That would be a slow process since a signal from Earth currently takes 20 hours and 33 minutes to reach Voyager 1. Receiving the spacecraft's response carries the same delay. Dodd went further to say that there were some big challenges for the engineering team, but if there were a way to solve this issue with the AACS, the team would find it. And so they went to work and eventually found out the problem. The issue with the Voyager and why it sent out confusing messages was that the AACS started sending telemetry data through a computer that was no longer working. In fact, the computer hadn't been working for many years. NASA's solution was to instruct the AACS to start sending data home through the right computer, because a dead computer corrupts onboard data. After this, the NASA team needed to know why the Voyager switched computers in the first place, because it could happen again if left unchecked. After a series of studies, it was discovered that it got an incorrect command from another onboard computer. According to NASA, contrary to Voyager 1, the twin Voyager 2 probe, also launched in 1977, behaves normally. The power the twin spacecraft can produce is always falling, and mission team members have turned some components off to save juice, measures they hope will keep the probes working through at least 2025. However, one question that people still ask is, how did these sophisticated space probes come about in the first place? The creation of Voyager. Having been in space for 45 years, scientists find it hard to believe that the space probe is still working properly since it wasn't even expected to last this long. Initially expected to last just 5 years, the probe beat all imaginations and has lasted for 4.5 decades, discovering new information that would help broaden our understanding of the cosmos. Now, you may be surprised that this sophisticated piece of scientific ingenuity, which has defied all odds for years, came about simply because the scientists at NASA discovered a piece of information by chance. A certain Michael Minovich realized that a spacecraft could capitalize on the gravitational force on a planet to propel itself further into space. This information resulted in the creation of the twin space probes, Voyager 1 and Voyager 2, back in 1977. These space probes were tasked with the original mission of studying Jupiter and Saturn, but later, Uranus and Neptune, 2 giant planets, were added, bringing the number of planets to study to 4. What's the future like for the Voyagers? The initially planned duration for the Voyager mission had been only 5 years, but it has expanded that by nearly a factor of 10. Now, nearly 50 years after launch, they're still very much operational and still racing out of the solar system at a rate of about 500 million kilometers per year. If things go well, Voyager 1 and 2 will probably continue operating in outer space forever, but the hard truth is they'll eventually run out of fuel. The plutonium inside their RTGs has a half-life of about 88 years. Science students probably remember from high school chemistry class that half-life is the time it takes for half of any element to decay away. 46 years isn't 88 years, but it is long enough that a substantial portion of their fuel has vanished into the chemical ether, as it were. Less plutonium means less heat, and less heat means less energy. Both Voyager craft are experiencing a power decline of about 4 watts per year. In response to the power drain, and in an attempt to prolong the Voyager's lives, engineers at NASA have strategically turned off instruments and systems to reduce the load, prioritizing the instruments most likely to send back useful data about interstellar space. In 2019, the team at NASA turned off the instrument heaters to conserve energy and allowed Voyager 2 to dip into reserve power in early 2023, moves that should extend the spacecraft's operational life. At the moment, NASA hopes to extend their mission beyond their 50th birthdays, and they could potentially send back signals until as late as 2036. After that, they'll likely be too far away to link up with the Deep Space Network and get signals back to us. If they ever reach another star, they may receive a hero's welcome from the future humans living there. They deserve no less. It is speculated that as long as Voyager 1 doesn't collide with anything, and as long as it is not retrieved, the New Horizons space probe will never surpass it, even though it was launched from Earth at a higher speed than either Voyager spacecraft. The Voyager spacecraft benefited from multiple planetary flybys to increase its heliocentric velocities, whereas New Horizons received only one such boost from its Jupiter flyby in 2007. As of 2018, New Horizons is traveling at about 14,000 meters per second, 3,000 meters per second slower than Voyager 1, and it is still slowing down. Now, while the Voyagers will only last a little longer, their golden record will not be easily destroyed, and they will carry on the mission after them. Voyager 1 is expected to reach the theorized Oort cloud in about 300 years and take about 30,000 years to pass through it. Though it is not heading towards any particular star, in about 40,000 years, it is said to pass within 1.6 light-years of the star Gliese 445, which is present in the constellation Camelopardalis and 17.1 light-years from Earth. That star generally moves towards the solar system at about 119,000 meters per second. According to NASA, the Voyagers are destined, maybe forever, to wander the Milky Way. In 300,000 years, it will pass within less than 1 light-year of the M3V star TYC 3135-52-1. The latest findings of Voyager 1 and 2. The two Voyager spacecraft keep expanding our horizons more than 4 decades after their launch. Having flown past the giant planets in the late 1970s and 1980s, Voyagers 1 and 2 are now well beyond all their planetary targets, with Voyager 1 more than 5 times farther out than Neptune and Voyager 2 not far behind. During the past decade, both spacecraft reached an entirely new realm in their travels by entering the interstellar medium, the tenuous material that fills the vast space between the stars. There, the spacecraft continues to make discoveries. Researchers have been surprised by the interstellar magnetic field, its strength, and its direction. And the new data have even fed controversy over the geometry and activity of the heliosphere, the Sun's magnetic domain. It has long been assumed that the heliosphere has the shape of a comet, or perhaps it is instead more spherical. And does it expand and contract when sunspots wax and wane, or is it more stable? The spacecraft has offered up some tantalizing and clearer clues. Voyager 2 shot out from Earth in 1977, and a few days later, it was followed by Voyager 1. They weren't the first spacecraft to reach the nearest of the giant planets, though. That honor is reserved for Pioneers 10 and 11. Notwithstanding, the Voyagers were more sophisticated than the Pioneers and made many startling discoveries. It appeared that Voyager 1 took a shorter route than Voyager 2, and as a result, even though Voyager 2 was the first to leave Earth, Voyager 1 overtook it and arrived at Jupiter in 1979. It found the planet's colorful moon, Io, and spotted active volcanoes. 1980, Voyager 1 zoomed past Saturn, spying on intricate details in the planet's rings. It also discovered the first nitrogen atmosphere beyond Earth, around the moon Titan. Voyager 2 took the more scenic route. It visited Jupiter in 1979 and Saturn in 1981, a year behind its twin, and then ventured past Uranus in 1986 and Neptune in 1989. Voyager 2 provided outstanding views of the green and blue planets and surprisingly spotted geysers on Neptune's large moon, Triton. After all the sightseeing, the spacecraft then headed for interstellar space. As astronomers have defined it, the interstellar medium begins where the solar wind, the outflow of charged particles from the sun, ends. This ionized gas, or plasma, presses against the cooler, denser interstellar plasma flowing around it like a pebble obstructing water in a stream. The sun-carved cavity is called the heliosphere, and its edge is the heliopause, just as the top of Earth's troposphere is called the tropopause. Voyager 1 broke through the heliopause on August 25, 2012, at 121.6 astronomical units, about 4 times Neptune's distance. Whatever the heliosphere's exact shape, whether comet-like or spherical, Voyagers 1 and 2 continue to dart away from it. By year's end, Voyager 1 will be 155 astronomical units from the Sun. The spacecraft's signals, traveling at the speed of light, will take more than 21 hours to reach us. When a corrective maneuver was made to Voyager 2, which arrived at Uranus in 1986, it discovered 19 moons on the giant ice planet that were completely unknown to NASA. After that, the space probe started its main mission. Neptune took 9,000 images and discovered 9 moons. Upon a closer study of Neptune's largest moon, the space probe discovered that its diameter wasn't what NASA originally estimated. The insightful discoveries made on the 2 ice planets, Uranus and Neptune, were truly amazing. It was gathered that the material essence of the planets isn't frozen, but made of very hot fluids that consist of explosive compounds like ammonia, water, and methane. It was also discovered that the diameter of Uranus is 4 times bigger than Earth's. About 10 years ago, the Hubble telescope captured a large white spot at the top of Uranus's atmosphere. Voyager 2 discovered that this white spot was a giant storm spinning at high speed, about 89 miles per hour. What you'll not believe is that the storm was calculated to be bigger than the entire United States. That's not all. It was also discovered that the clouds in Uranus were freezing due to methane and ammonia. The temperature of the clouds would sometimes be 323 degrees Fahrenheit. Compared to Saturn, the rings of Uranus were much fewer and more spread out. Neptune is the farthest planet from the Sun. It is about 3 billion miles away from it, while Earth is just 90 million miles away. Yet Neptune bears similarities with Uranus. Neptune's diameter reaches about 31,000 miles, and its mass is about 17 Earth masses. Voyager 2 discovered unique weather conditions in Neptune, like bright clouds in the atmosphere and storms spinning at top speed, up to 1,305 miles per hour. The wind was recorded as the fastest wind ever seen on a celestial body. As to why the wind is so fast, it is attributed to the lack of solar energy reaching Neptune. Voyager 1 is currently 14.6 billion miles away from the Earth and is still exploring space, even though most of its equipment has been shut down. Both Voyager 1 and Voyager 2 are still holding on and will hold on till they finally run out of juice. They continue to transmit data about interstellar space. Both can measure the electron density because they detect the radio waves generated when solar eruptions cause electrons in the interstellar medium to oscillate. These eruptions should become more frequent as the sunspot cycle peaks around 2025. The current measurements indicate that the interstellar density has increased further from its value outside the heliopause, but no one knows what will happen next. Voyager 2 still has a working plasma instrument and will keep tabs on the interstellar temperature. This temperature will likely fall because astronomers have measured the local interstellar medium's temperature to be only 7,500 Kelvin. The high temperature just beyond the heliopause probably results as the plasma there gets compressed and heated. Both spacecraft will monitor the interstellar magnetic field. If the magnetic field gets compressed and strengthened near the heliopause, then the field should eventually weaken at greater distances. And Voyager could even see the magnetic field change direction, just as researchers had expected at the heliopause. The ultimate goal is to sample the unperturbed interstellar medium, a space so distant that the heliosphere barely affects it. The interstellar medium is of interest to astronomers partly because it is the spawning ground of stars and where they deposit newly minted chemical elements, which future generations of stars and planets will inherit. In addition, astronomers must peer through interstellar gas and dust and correct for their effects to study stars and galaxies. Although researchers use ground-based and Earth-orbiting telescopes to observe the interstellar medium from afar, the two spacecraft yield unique data on its density, temperature, and magnetic field by actually being inside it. No one knows how much longer the two spacecraft will survive. They must stay warm so the fuel to keep their antennas pointed toward Earth doesn't freeze. Voyager's heat comes from plutonium, but as the radioactive element decays, it provides less and less power every year. Surprisingly, Voyager 1 is the warmer spacecraft, even though it's farther from the Sun. After NASA launched Voyager 2, engineers noticed it was colder than expected, so before launching Voyager 1, they added more insulation to keep it warm. That extra warmth may well prolong the spacecraft's life, and because Voyager 1's plasma instrument failed, that instrument didn't consume any energy, leaving more room for heating the spacecraft. As a result, the Voyager exploring a more distant, and hence likely more interesting, region of space may continue to return data even after its mate falls silent. If we make it to 2027, it would be 50 years since Voyager was launched. Speaking of discoveries, NASA made a shocking, unexpected discovery that completely blew people's minds. NASA's shocking discovery of a super-Earth scientists, including astronauts and scientists, have not ceased to amaze us, and they are beginning to topple our understanding of planets and exoplanets. Exoplanets are the planets beyond our solar system. The newest spaceborne instruments, including those on board NASA's James Webb Space Telescope, are designed not just to detect these distant worlds, but to reveal some of their characteristics to expand our understanding of them further. The characteristics include the composition of their atmospheres, which could offer clues to the possible presence of life. What NASA just discovered is different from what is expected. It's a whole new world. The recently discovered super-Earth might be making its appearance at just the right time. Just like our major star is the Sun, the super-Earth's parent star is a red dwarf, smaller and cooler than our Sun. Several such stars are known to host small, rocky worlds. At the moment, they're our best bet for finding habitable planets. These planets make far closer orbits than those around stars like our Sun. But because red dwarfs are smaller and cooler, the planets can crowd closer and still be safely within the star's habitable zone. The tighter orbits also mean those that cross the faces of their stars. That is, when viewed by our space telescopes, cross far more often. This new world, tagged TOI 175b, has joined the list of habitable zone planets that could be more closely scrutinized by the Webb telescope, perhaps even for signs of an atmosphere. Much will depend on the planet's other properties, including how massive it is and whether it can be classified as a water world, making its atmosphere, if present, more prominent and far less difficult to detect than that of a more massive, denser, and drier world, likely to hold its lower-profile atmosphere closer to the surface. If the possible second Earth-sized planet in the system is also confirmed, it will become the smallest habitable zone planet discovered by TESS. The discovery also exceeded early expectations for TESS by finding an Earth-sized world in the habitable zone. NASA, almost Voyager 2. Forever. Remember Suzanne Dodds? His team transmitted a routine command to Voyager 2 on July 21st, and that was when the unthinkable happened. They accidentally sent the wrong version, which pointed the interstellar probe's antenna slightly away from Earth. As usual, the scientists expected to receive data. However, they heard nothing at all. This seemingly small error almost made humanity lose its connection with the popular spacecraft, now 12.4 billion miles from home. Along with its twin Voyager 1, humanity's farthest-flung spacecraft is still collecting data. The team settled on a solution: blast a shout command in the probe's direction, telling it to adjust the antenna and point it back towards Earth. The craft could still receive the signal, even though its antenna was already offset, if the signal was strong enough. They carried it out on the morning of August 2nd, sending the highest power signal they could, using the high-elevation, 70-meter, 100-kilowatt S-band transmitter at the communication station in Canberra, Australia. The station is part of NASA's Deep Space Network, an international system of giant antennas managed by JPL. There was no guarantee of success, and it would take 37 hours to see if the solution had worked or if they had to find another way before the Voyager was lost forever. Unsurprisingly, the entire team spent a sleepless night waiting and hoping. And then, there was finally some relief. It worked. Contact was restored on August 3rd at 9:30 p.m. Pacific Time. They went from "oh my God" to "thank God." If, by any chance, the attempt had failed, the team would have only had a single backup option left: the onboard flight software's fault protection routine. Multiple fail-safes were programmed into the Voyagers to automatically take actions to deal with circumstances that could, in any way, harm the mission. The next routine was expected to kick in mid-October. If it worked, it would have generated a correct pointing command, hopefully adjusting the antenna in the right direction. Now, while the NASA team restored communications with their beloved spacecraft, it won't be the last scare they will be given. The Voyagers have aged well past their prime, and their dwindling power means that their scientific instruments can be run for only a few more years. The Voyager probes are powered by radioisotope thermoelectric generators, which convert heat from the decay of radioisotope fuel, plutonium-238, into electricity. But unfortunately, fuel sources have been decaying for a long time. To conserve what little power they have left, the Voyager team has already shut down the heaters for all of the scientific instruments, which have continued operating normally despite that. In the coming years, the magnetometer, plasma wave surveyor, and charged particle detector will likely have to be shut down, one at a time, to ensure a few more years of interstellar science. Everybody was exuberant that they had the spacecraft back, but it also made them realize that this mission could end any time, whether a human error was involved or just because the spacecraft was old and broken. It makes you value what you have. What are your thoughts about the message of Voyager 1? Let us know in the comments. Thank you for watching. Remember to like and subscribe to see more videos.